Everyone, my name is Salar and this is Saldi channel. So this lecture is another chapter of my tutorials about mechanical metamaterials, and this lecture is about CAD modeling of FCC Lattice Plate Structures, which you can see the final structure in this screen. So let's just undo what I have done to reach this step and again do it, so to see what's the process of this CAD modeling. Okay, as you could see, here is a simple cubic unit cell which we are going to use as a reference geometry, but also you could still have it at the end of your CAD modeling as a reinforcing frame, or you could just hide it and stick to your singular form of FCC Lattice Plate Structure. So let's create a reference plane between these 3 points to create our geometry. Okay, let's just find out that what we should draw. We should draw this type. Okay, let's just normal to this plane. Again, check if you're okay or not. Okay, we're cool. Okay, let's create 3 lines. I want to do it this way. 1 line here, 1 line here, and 1 line here. Okay, it's a little complicated at the first stage. Let's just see that we choose the right angle of being normal to this plate, because if we just normalize from this view of port, you could draw the wrong plate, but now we are clear and now we are good. We have created the right geometry that we wanted. So let's just extrude this plate for 1 millimeter mid-plane unmerged, and okay, let's just hide this plane to see what we have drawn. Okay, let's just go to isometric type. Okay, we need to create 2 different reference planes, one for patterning, which is this plane, and also one for mirror process, which is going to be this plane. Okay, let's just create a center line here on this plane, so we could do a circular pattern around this line. Okay, I'm going to go to feature, circular pattern, choose this direction, choose this body with 90 degree and 4 pieces of this body. Okay, as you can see, we have create a half part of our FCC lattice structure, and at this point we just need to mirror everything toward this plane so we could create the final structure. Okay, just choose mirror. The face would be this reference plane, and bodies to mirror is everything except our frame, which is mean that this is going to be our final FCC lattice plate structure. But let's see two different options that we have for our final lattice structure. Okay, let's just hide this simple cubic reference unit. So as you could see, I think it's better to hide these planes too for a better view. Okay, also these sketches I want to be hide. Okay, as you can see, we have some harsh and not well organized corners or edges, so you could still stick with this structure. There's no problem, even in terms of mechanical properties. You may have some stress concentrations, but you could still just forget about it. Or you could trim this structure. So the first option is to use this structure, as you could already seen in this viewport, or you could just trim this structure. So for the trimming process, you need to hide your simple cubic unit cell and just do some simple extrude cuts for this lattice. Okay, I'm going to choose front plane, create some sort of rectangles just to use it for the trimming process. You could do it with setting a simple amount of dimensions for these rectangles, but I'm going to use it without dimensions. Okay, so it's going to be through all direction. Just choose every contour, and I also want the direction too. Okay. As you could see, I have trimmed this lattice, and everything is much better. So I could do it for another directions too, and trim this on other corners too. Okay, it depends on you if you want to have more smoother or more organized corners, but it depends only on you. So okay, I hope this tutorial helps you. As always, subscribe to my channel, ask your questions through comments or through my LinkedIn, and also you could still find this model STL file on my Cult 3D profile, and I will share the link for you on the caption. Okay, have a nice weekend and be happy, and don't hesitate on asking your questions. Bye.